not very secure. So, right, well, over to Hamad on Incident Groundhog Day. Thank you.
Thanks. So 8 years, math, unbelievable. Time flies. I remember early days, DevOps London used to give this glass saucers, heavy one. I expect one of them later on. So has anyone here seen the movie Groundhog Day? Okay, great. So those who have seen it, you're going to have a few more moments of laugh. Those who haven't, no, it's okay. My name is Hamad. It's less relevant who am I or what is my background, but I'm more excited to talk to you about a unique experience that we did at Uptime Labs on incidents. It was first on its kind. So, but first I want to take you through a journey, imaginary journey. So can I ask you to close your eyes and follow my words? Maybe not close your eyes, I don't want to be responsible for any mishaps, but still follow me with this journey. Imagine you're working for a large online retailer, maybe Amazon, while we're sitting here, and you're an engineer. 6 o'clock in the morning, your alarm clock goes off, wakes you up, and you remember that it's a Friday, but not any Friday, and it's an important Friday for your business. Revenue targets depends on business being up and running and selling on this day. Everything starts well until it's not. An issue comes up, you get a call from your incident manager or from customer services that there's a problem. It gets very ugly. Many of you and your colleagues start scrambling around to work out what is going wrong and trying to fix the issue. After loads of stress, things works out at the end and day goes well. Fast forward 24 hours. It's again Friday. Your alarm clock goes off 6 o'clock in the morning. It's an important day, Black Friday. And the same story happens again. That's a fourth miracle. Okay, we're back in. Is it in my control or? No, it's nothing to do with me. Okay, great. And you go through the same experience 18 more times. And if you manage to live until the end of it, what have you learned? I bet that if you manage to get through all 20 days, you will learn a lot about responding to incidents. But unfortunately, that experience can't happen. We can't experience the same incident over and over and over again. And that's why it's really hard to learn about incidents. I specifically say learning about incident response rather than learning from incidents. We all do post-incident reviews and learn what happens during an incident. But we don't do much, and it's really hard to learn about responding to incidents. Because incidents by nature, they're surprising. There is a huge amount of stress during incident response, a lot of cognitive load on people involved, and it's very complex. And unless you can step back and observe over and over what happens, it's very difficult to learn from it. The scientific method to learn from about complex phenomena is they keep all the variables the same, and each time they change just one of the variables and study the impact of it. But that's not possible in the world of incident response. Even if all aspects of mechanism of the incident stays the same, an incident happens again, the fact that it could be different day, it could be different people involved, it could be the software is changing all the time thanks to continuous delivery. Or even if all of that stays the same, the fact that you have seen the same incident before changes the way you react to the incident. So it's really, really hard to experience the same incident twice. Maybe unless we can jump on a time machine, go back, and forget about what we have seen and experience it again. Which unfortunately, that's not possible either. Which is a terrible news for our industry, which is in desperate need of getting better at responding to incidents. All aspects of human life is depending on digital services and get worse and worse. Just think about CrowdStrike and the impact of it. So that's a shame that we can't learn from incidents. But what if we could? What if we could experience the same incidents more than one and study it? That was the challenge we set ourselves to do at Uptime Labs, to create the same incident and study it. We borrowed a concept called stage word from work of Professor David Wood. And if you're interested on that, there's a brilliant talk from Marissa Grayson at Learning from Incident conference that I encourage you to walk. But basic idea is you don't need to replicate all the details of an experience to recreate it. You just need to pick up enough details so let you elicit important skills and experience to learn from an incident. And that's what we did. So we picked up cohort of 20 incident responders with different levels of experience, seniority, engineers and different roles as well, like incident managers, across different industries and companies. And we took them through that experience. The hardest part of the experiment was deciding what are the elements of this stage word that we want to replicate and make as close as possible to reality to have a valid scientific experience. And we settled on the 4 aspects. The first one was we're dealing with engineers. The tech should be very realistic. The failures should be very realistic. So we spawned up the exact architecture that you would see with the real system. So when they fail for real, and made that available on the internet as well, so they could see it. Then it was the social aspect of it. So incident response is a teamwork. You rarely solve it on your own. You work with a group of people. So we created also an organization around the people who are responding to the incidents, albeit all the characters were AI, but they were replicating real life behaviors like a demanding CTO or a customer services that desperate to pass information to the customers, or very experienced engineer that is very opinionated. The third element was tooling. Engineers love their tooling. So we created the realistic observability tools that they could use for troubleshooting. And finally was the communication platform and tool. So they could use the same tool again they use in real life. So now that the whole setup of the stage word was ready, it was time to think of an incident scenario. Who's familiar with Schrodinger's plate idea? These plates at the same time, they're broken and not broken. As soon as you open that door, all of them will break. So we borrowed the same concept in creating the incident scenario. It was a set of API keys, corrupted by deployment, but the cache has not expired yet. So everything was working. And was waiting either for cache expiry or a poor engineer to refresh the cache for everything to fall apart. Now, as if that was not complex enough, the issue also was designed to affect only certain geographies in that online shop world, which was Turkey and Japan, the current problem with the currency exchange in those countries, to add to the complexity, which made me wonder, people designing the scenario, what horror they have gone through in their childhood to make it so complex. But nevertheless, it's realistic. We all have dealt with incidents like that. So, after this 20 poor souls going through that experience, what we have learned, I'm sure you're all eager to find out, to learn about their struggles. And while it's very interesting to read about people's struggle rather than experience it yourself, I can tell you, it's far more interesting to watch them struggle than doing it yourself. So out of 20 participants, 13 of them managed to restore the service within the 25 minutes time limit. Some of them did earlier, some of them just on 25 minutes. But if their ability, basically time to recovery, really doesn't tell you much about how good or bad incident responder you are. There's no correlation there. Late Dr. Richard Cook once said, result comes from experience, experience comes from bad result. So all of them are good, no matter how they did. And then when we looked into the results and actions and activities of the participant, we decided to borrow John Olspo's work on incident response activities. So basically, he groups activities involved in incident response into 4 categories of diagnostic, therapeutic, recruitment, and status reporting activities. So we look at them through these lenses. If you're interested to learn more about it, I recommend you to watch his talk at SRECon 21. So diagnostic activities. So these are all the activities that involve absorbing signals that are coming to you, forming hypotheses of what could have gone wrong. This screen is really helping me here, and even decide activities like deciding severity is part of diagnosis. So we had some interesting observations. The first one was the sheer number of signals that comes from the system and people involved in the incident makes it extremely difficult to work out what signal is important and worth elevating and which one is not. Sometimes it makes it impossible because the signal and evidence, the value of a metric, it seems very irrelevant until later on you discover something. So that's very, very difficult. The other observation was that out of the participants, all apart one of them set a severity for the incident, but there was no pattern. We had severities from 1, 2, 3 people, like randomly, not randomly, but based on their thought process, pick different levels of severity. The interesting fact was that no matter what severity you picked, they didn't have much influence on outcome of the incident, which kind of reminded me of an interesting talk from M. Roop, again SRE-Con. What is severity but a lie agreed upon? So the severity of the incident in this case didn't make a difference. What we observed though, people who spend a lot of time on deciding if this is a SEV 1 or SEV 2 or SEV 1.5 ended up having less time fixing the incident, and they were disadvantaged. Now comes the scary part. This word I always struggled with, therapeutic, from the moment I started talking 4 years old. So I try to pronounce it correctly. So therapeutic activities, these are all the interventions that incident responder does in attempt to fixing and resolving the incident. Not all of them will fix the incident. Maybe some of them won't have any impact, or you may need few of them to fix the incident. So activities like rolling back or restarting the service. Couple of interesting observations here. Again, all apart one participant decided to roll back a service called currency service. It's interesting in both cases it was all apart one. I need to check if it's the same person who didn't assign severity. But as scenario unfolded, all the evidence were pointing into currency service having a problem. And interestingly enough, 20 minutes earlier there was a change on that service. So it was rather logical, okay, let's roll it back. And that's great. But it didn't make any difference in restoring the service. So were they wrong in rolling back currency service? Were they right? Did they waste the precious time of incident? What we realized that no matter what was the impact of that action, it was actually a good thing to do. Because there's a magic with therapeutic activity. As soon as you take an action, immediately becomes diagnostic. You have a piece of information that you didn't have a minute ago. So those who rolled back currency service now knew that the rollback wouldn't make any difference. And they had another piece of information to hand to solve the problem. The other thing that we observed is incident response is not a linear progression that many people believe. it's circular. You do something, you realize that, oh, whatever you thought so far was wrong. So you go back to square one and try again. So it's very iterative activity. The third group of activities, recruitment activities. So this is about finding and bringing people with expertise and authority who can help with resolution of incidents. Now, the caveat in our experiment was, first, it was like one real person and everyone else AI, so not much of an opportunity to recruit others. We tried to have very friendly AI people who can interact with the human. And also the experiment by design was in a way that not one person on its own could solve it. So you had to interact with others and elicit information to be able to fix it. But what we noticed was very distinct two group of people. We call them solo members and band members. There were a group of people that jumped in Grafana here, there on the servers, tried to solve it on their own. Very few communication. And the group of people really seek information from others and try to form a team activity. You can see that in the two graphs so on the presentation. So we have an internal tool that we use to analyze people's activity during incident response. So the bars you see here, they're showing communication that the member did with other people, and the color of it also means the length of conversation. So in this experience, people who had a better teamwork, they ended up resolving the incident quicker. And examples of that, I'm sure it happens all the time, is like inviting people to come and share their opinion or form an investigating team. The last group of activities, I call them status reporting activities. I call them necessary evil. So incident response is a team effort. While there is a small group of people busy trying to solve the problem, there are a larger group of people desperately watching your effort from sidelines and in need of information, because they may need to do activities or they may need to respond to customers or stakeholders, and the information coming out of the core group will help them. But there's a beautiful paradox here. How much time you spend in sharing information with people who are interested, and how much time you focus on fixing the incident. Because if you sway one side, you will miss on the other side. So deciding on that balance is very difficult. So what did we observe? People who got sidetracked by engaging in conversation, especially with senior management, looks like the senior your rank is, the more likely people try to engage with you. They ended up having less time and less cognitive capacity to fix the incident. So they got the balance wrong. And the other observation was some people used techniques to have very concise communication. They used templates, for instance, very specific. Oh, this is the incident, that's what happened, and when the next update would be, and stick to their template. So that also, it makes it a lot easier for them to focus on the actual incident. And there was also another interesting observation with these people where it was obvious that they were using their muscle memory. So they had in mind that, okay, when an incident happens, I'm going to do these activities in the X many minutes beginning. So they didn't have to really think what they need to do. So they had that experience there. So I went through a lot of detail. Hopefully you're still with me so far. But just to recap, what we learned from this experiment. The most important point that really strongly come out is incident response is a multi-threaded attention management exercise. A lot of activities going on at the same time, huge load on everyone involved in the incident. And the more you can distribute that activities among other participants in an incident, the easier, first of all, experiences for yourself, and more likely you are to solve an incident. So the people who managed to leverage the team more than others, they got the result faster, they had a better experience. Many people will observe that they used techniques to reduce their cognitive load, so following muscle memory that they build over time, over experience of years of dealing with incidents, like using template or calling people by their specific names rather than sharing vague names or vague statements. They had a better result. People who spend a lot of time and energy on deciding about severity, they certainly lose out. And also people who manage to balance the communication with the stakeholder, that they had a better result as well. So what is next from here? This is like all scientific experiments, there are some weaknesses and caveats. The most important one is everyone joining this experiment, they knew that there's an incident that they need to deal with. That's not the real case. You don't go to work knowing that at 10:15 there will be an incident and you will be resolving it. So that's the big caveat. The second caveat was incident response is a team sport. In our experiment, it was just one human, and the rest of them were AI. So in future experiments, we want to address these two shortcomings, and I'm sure we will share the results with you in due times. So we're planning experiments with, we call it Team Groundhog Day, so with more than one person. So I think that would be very interesting to see how people interact with each other. Experiment with no time limit. There's no 25 minutes, you can go as long as you can, see what happens there. And having people from different skills and roles involved, like executives or customer success, and see how they behave in that experiments. Again, I come back to the point that learning about incident response is a really pressing matter for our industry. We not only owe it to consumer of our services, which is pretty much all humanity out there, but also experience of our colleagues to get better at incident response. So I invite all of you to join these experiments. You can sign up with this QR code and help us and help you to learn more about incident response. We will be sharing the results with everyone as well. And finally, I'm going to leave you with a quote from Professor David Woods, which is, resilience is a verb. What it means is, resilience is not what you have, is what you do within your organization, how people work within your organizations. Alongside all wonderful stuff that you do in terms of building reliability and redundancy within your services, I strongly recommend you to spend time and invest in running drills and experiments like stage work to scale up your people. Because when all other wonderful technical redundancies fail, and they will happen, then it comes down to your and your team's skill set to save the day. And that's why it matters a lot. So in this study, we used a great work of a lot of people here. I just keep this slide here. You can take a photo of it. But to mention John Olspa, Professor David Wood, late Dr. Richard Cook, Marisa Grayson, M. Rupert, and my good friend Stuart Rimmel, I think is somewhere in the room over there, who led the research activities. Thank you very much.
Okay, we have time for questions. Any questions?
You mentioned at the end the idea of training and practicing and so forth. How much attention have you paid to things like that? So leadership skills, soft skills, problem-solving ability, all of these kind of things. Because I'm kind of minded of two things. My early history was in the oil industry, and I had to be able to identify and manage problems very quickly in lots of ways. And that's a skill. And recently the film Sully, if you look at that,
Yeah.
which is a great example because he was in the incident, and when they tried to replicate it, people knew it was an incident.
Yeah, exactly. That mentions it there.
Have any thoughts on those points?
Yeah, absolutely. And most of the focus in the experiment was on softer skills, communication, coordination. I think, from my perspective, that's far more important than the technical skills. Most people, most engineers anyway, they got a basic level of technical skills. What makes it really hard is lack of those softer skills and ability to work as a team. So I totally agree with your point.
Cool. Any more questions?
Yeah.
Right.
Shall I speak here?
Yes.
Yes, ma'am.
Okay. Very nice presentation, by the way. Can I ask, similar to that, what the gentleman was saying, as you know that at the end of the day, an incident is for you to learn something, okay, as you said, okay? And I think, so let's say, for example, any sort of incident just happened, as you know, but then at the same time, I think, either that team or that company involved in that incident, either they really need to have a sort of a culture within the company or the team itself to learn about it and not basically think of it as a failure to them personally. Don't you think?
Yeah, absolutely. It's incidents are opportunities to learn, and the biggest signs that will tell you if where the journey or of a company is in terms of will they have a better, more reliable service is how they react to incident. Do they celebrate it, or do they see it as a big problem and looking ahead to cut?
Cool. Last question.
So, did you have to choose an example problem space where the participant had familiarity with it to make it relevant to their experience, or were they thrown into something they knew nothing about? I guess I'm asking, how generic is this? Would we need to create whole environments for every individual company experience at every division, or is there generic learning that comes from how do you deal with this? But
There,
do they have enough knowledge to understand how to deal with it? I'm quite confused.
So, amazing question. So initially we thought that actually makes a big difference for people to be familiar with the domain. So if we bring people from financial services, the architecture should be similar and familiar to them. People from retail need to deal with the retail platform. But after doing initial interviews and experiments, we realized that it doesn't matter. Familiarity with the environment, it doesn't matter. If you look at it, people in our industry, they freely move engineers or incident managers between different industries. From finance, go to work at retail, and still they're effective. From retail, move and go to social media. And the experiment we saw was a proof of that, because participants were from different industries, not all of them from retail. And many of them who successfully resolved the incidents, they were not from retail.
Okay, that's it. Thank you so much. Any other questions? You can find him afterwards.